Hey, Algebra 2, this is Mrs. Tran-Bloom here, recording for our Unit 2.2, Graphing Piecewise Functions. So let's start. The following graph is called a piecewise function. And you guys remember from Unit 1, a piecewise function is defined by two or more different equations applied to different parts of the function's domain. So if we look at this piecewise right here, students, how many pieces do we have? 1, 2, and 3. We have 3 pieces. Are they rays or segment? Well, remember, rays, what's going to happen to rays is that it starts at one end and it goes on forever. So piece number 3, it's a ray. And a segment is when we start at one corner and we end at the other. So we have one ray and 2 segments. Okay, this is a segment. This is also a segment. So it's a mix. We have 1 ray and 2 segments. Is it continuous? Remember, students, continuous meaning that can I graph the entire function? Okay, all 3 pieces equals one function without lifting my pencil. So we could try, we can say, okay, I can trace here. Well, I can't go to the second piece without lifting up my pencil and make another closed dot. So since we have to lift up our pencil, it is not continuous. Graphing a full piecewise linear function. These functions will be made of smaller pieces, not one full line or graph. Like when graphing rays and segments, we sketch the boundary, aka restriction, above the graph. Next, we make a table of values for each ray or segment, we have to decide which one, and use the boundary number and at least one other value to sketch that piece. After all pieces are drawn, we check for functionality with the vertical line test, meaning that, hey, is it a function after all? Meaning that if we make a vertical line, is it going to pass the vertical line test? Does it intersect more than once? If it does, then it's not a function. Then we answer the question, is it continuous or not? Now, students, continuation, okay, of a function, meaning that can I draw the entire function, all the pieces, without lifting up my pencil? So first, just like what it said, students, we are going to decide if it's going to give us rays or segment based on the restrictions, okay? So the first one, it has x must be less than 0. So everything that's less than 0, here's the number 0, we have to go to the left. Then close circle, because it's inclusive. Inclusive means if you have an equal sign right there, it goes to the right. So the first piece, everything to the left of 0. Okay, that's your boundary. Then the second piece, we have to pick every x value on the right side. So we have 2 pieces here. So that's what I'm going to start with. I'm going to write first piece and second piece and start with the table. Okay, so first piece. Make your table. We want to start with the first number, which is 0, and because it does not have an equal sign, we know for sure this is going to be an open circle. Then we plug it into this first piece. So 1/3 times 0 minus 6 plus 2. Well, 0 minus 6, students, is going to be a -6. A -6 times 1/3 is now a -2, and a -2 plus 2 is 0. So your first dot is an open circle at 0, 0. Now we can go and pick every single value that we want when it's less than 0. So I'm going to go and pick -1 because -1 is less than 0. So again, we will plug it into the first piece. So -1 minus 6 plus 2. Well, negative 1 minus 6 is going to give us a negative 7. Negative 7 times a third, students, is negative 7 over 3. Drop down the plus 2. And negative 7 over 3 is exactly as negative 2 and a third. And then I want to add 2. Well, negative 2 and a third plus 2 is now going to be a negative 1/3. Well, we have a fraction here, so that's okay. We can have fractions in our answer. So it's going to be negative 1 to negative third. So here's negative 1 and negative third. It's right there. Well, I can keep on plugging values. So I'm going to do one more value, and then we will talk about using the slope to help us out as well. Since, okay, this has a multiplication of a third, we want to pick values that will be multiples of that. So the next one I want to pick would be a nice value that will help me not have fractions if I don't want to. But there's nothing wrong with there's nothing wrong with fractions, okay? All right, plug it in. 1/3 times negative 3 minus 6 plus 2. Well, just like earlier, we have 1/3, negative 3 and a negative 6 is now negative 9 plus 2. Negative 9 times 1/3, students, is going to be negative 3, and negative 3 plus 2, this is a negative, is going to give us a negative 1. So negative 3 go to negative 1. Well, that's pretty good, right? We have 3 dots. That should help us out with graphing our line. But students, this is a slope of 1/3. We can continue, and once you have 1 dot and you know that you're supposed to go on the left, you can continue with a slope. 1/3 means is rise over run, so we can go down 1/3, make a dot. Down 1/3, make a dot. You can keep going until you can't go any longer. And so now I'm just going to use a ruler and connect all of the nice dots that we have created. Make sure you are using a ruler as well, okay? Try to make a nice straight line. So remember, this is a segment. I'm sorry, this is array. This is array going to the left. All right, piece number 2 is going to be, I'm going to use blue, which is this one. When x is bigger than or equal to 0. So piece number 2, we are going to pick 0, and this is a closed circle because we have an equal sign right there. Let's plug it in. Negative 2 times 0 plus 5. Well, anything times 0 is 0, plus 5 is now 5. So we have our first 0 of 5, and we said close. I'm going to pick one more value, like 1, because remember, we want to pick values that are bigger than or equal to 0. So negative 2 times 1 plus 5. Negative 2 times 1 is negative 2 plus 5. That's going to be 3. So we're going to go 1 and 3. Okay, now we can again use your slope, which is that value of negative 2. Well, negative 2 is the same thing as negative 2 over 1. So since the top is negative, meaning that we go down 2 from the last point we plotted, and the bottom is positive 1, we go right 1, down 2, right 1, down 2, right 1. You can keep going until you don't want to go anymore. Remember, minimum to graph any line would be 2 points. But the more points you have, the better your line will be. In this case, we will have a ray. Okay, so this ray goes to the right. And look at this, we have 2 pieces. We cannot graph both pieces without lifting up our pencil, students. So this answer, is it continuous? It is not continuous. Okay, example 5. F of x equals to 3 pieces, okay? 1/2 x plus 5 when x is less than negative 4. So let's draw this ray out. Here is negative 4, open circle, goes to the left. Then in the middle, the second piece says y is always 3 when x is in between x is in between negative 4 and 3. Inclusive, close, because there's an equal sign right there. And before we start this piece, students, can you do me a favor and change this value? Can you make it into a 3 if it's not already a 3? So that should be read x is bigger than 3, okay? So change the 6 into 3 if it's not already changed in your notes. All right, so now that one, I'm going to make a ray, open circle, go to the right. Those are your restrictions. Okay, so the first piece, I'm going to use blue. All right, let's pick our first x value, which is -4. This will be an open circle because it does not have an equal sign, and let's plug it in. So 1/2 times -4 plus 5. Half of -4, students, is going to be -2. -2 plus 5, that's going to be 3. Now, whenever, okay, students, whenever you have a fraction here, you want to use values that are multiples of the denominator. So that way, when you plug it in, the numbers will turn out to be nice. So my next value will be -6, because -6 is multiple of the denominator 2, and then -8, okay? So let's plug it in. Half times -6 plus 5. So half of -6, students, is -3. -3 plus 5, that will give us 2. And similarly to this last value, -8 is what we have chosen. -8 times half is -4. -4 plus 5 is 1. So we know -4, go up 3, and we talked about open circle. -6, go up 2. -8, up 1. Now, if we want to keep going, students, this is a slope of 1/2. A slope of 1/2 can also be seen as -1 over -2, because that will also give us a positive half. So because I'm going left, I do want to use a -1 over -2, because that would say, okay, go down 1 and then right 2. Down 1, right 2. So minimum 2 points is required to graph a line, but if you want more dots, then you can use the slope as well, okay? Next, I want to go and do the second piece in orange. So second piece. Well, the second piece, we know that it's going to be a segment. We will start with the x value of -4 and an ending value of 3. Both of these will be closed circles due to the fact that we have equal signs right there. Well, look at the y value, students. There's no variable here on the y, so whatever we pick, y will always be 3. Now, in between the opening piece of the segment and the end piece of the segment, I want you to pick one more value. Normally, pick 0 when you can. So in this case, in between a -4 and a positive number, let's call it 3 this time, 0 does exist. And y value is always, 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 always 3 for that second piece, okay? So let's go -4, go up 3. Oh, we used to have an open circle, but this is now going to fill it up. And then 0, 3, and then 3, 3, and that's a closed circle. So that is a straight line right there. Now, last piece is going to be, let's put that, how about here, third piece. We are going to pick 3, but we know that this is going to be open circle because we do not see an equal sign. And then we're going to pick like 2 more x values, okay, like 4 and 5. All right, when we plug in 3, we're going to go -2 times 3 plus 9. -2 times 3, students, that will give us -6. Whoa. Well, it brought it back up to the top. All right. So -6 plus 9, that will give us an output of 3. And next, we are going to plug in 4. All right. -2 times 4 is -8 plus 9 is 1. -2 times 5, students, is -10. -10 plus 9 is going to be -1. So we are going to sketch that out. So we are going to say, okay, 3, up 3, open circle. But students, even if we have an open circle, the orange segment earlier had a close. So if it's if it's closed before, it is now still closed, okay? So our purple open dot at 3, 3 gets filled up with the orange from prior. All right, go 4 to the right, up 1, 5 to the right, and then down -1. Now I do want to keep on going a bit more. So I do see that I have a slope of -2 over 1. So normally if that's the case, student, you can go down 2 and right 1, down 2, right 1, down 2, right 1, down 2, right 1. You can go as many dots as you need it, so that way your line or your ray or your segment can be straight, okay? Okay, so we have 3 pieces. But because the 3 pieces, they connect, right? What does that mean? That means I can graph and graph and graph. Look at that. At no point I had to lift up my pencil. So is this continuous? Yes, it is. Woo, woo. So let's do this one. Example number 6, and I think this is our last one. Cool. All right, this one has 3 pieces. And the first one, we know it's going to the left and it's closed circle. The second one, it started at -1 and it ends at 4, closed circle. So that's a segment. And the third one, it starts at 4, open circle, and it's bigger than that, so we know it goes to the right. So we have 2 rays and a segment again. Okay, so we do want to make a table for the first piece. So I'm going to pick orange. First piece. And the first piece is this dude right here. We want to start at -1. And we have a closed circle. All right, and I want to pick some values that are smaller than that. -2, -3. So when x is -1, we're going to plug it in. Negative of a -1. That's going to give me +1. When x is -2, negative of a -2. That's 2. And same thing with this last one. Okay, so -1, go up 1, close circle, -2, go up 2, -3, go up 3. Now students, this piece has a slope of -1 over +1. So you can think of it 2 ways. You can leave it like that, or you can say, well, if it's a -1, I can technically have a 1 over -1 and still equals to -1. So if we use this right here, we can go up 1 because the numerator is positive and left 1. Up 1, left 1. Whatever dot we are using, it should still be on the same line as the first couple dots that we use on our table. So this is a nice straight line. Whee! Okay, so that is definitely a ray, and it went to the left and upward. Now, piece number 2, let's use black. Piece number 2 is a segment. So second piece, we have a starting value at -1, and we knew that was going to be an open circle, and we have an ending value at 4, and we talked about this being a closed circle. And in between a negative and a positive, I know for sure there's a 0. So let's plug it in. 3 times -1 minus 7. 3 times -1 is -3 minus 7. This is -10. Okay. Next, let's plug it in. 3 times 0 is 0 minus 7. This is -7. And lastly, 3 times 4 minus 7. So that's 12. 12 minus 7. So that's going to give me 5. Let's plug those in. -1. Down all the way to -10, open circle. 0 is now -7. And then my last dot is going to be 4, 5. Okay, that's a closed dot. Now, well, that seems to be like a really big gap from the second to the third dot. Okay, well, let's use our slope to check. Our slope here, students, it's m equals 3, or 3 over 1. So from the last dot, students, if it's 3 over 1, 1, 2, 3, up to the right 1. 1, 2, 3, right 1. 1, 2, 3, up, right 1. 1, 2, 3, right 1. See, we are on the same exact line. So this is correct. So this segment is looking awesome. Okay, next is our very last piece, and I'm going to use this. My last piece, we are going to have an x value starting with 4, but we know that's going to be open circle because I don't see an equal next to it. And I want to go to the right, so 5 and 6. Well, but look, check it out. This does not have a variable. So whatever we plug in for x, y will always be 5. So open circle at 0, 5. Well, it doesn't matter because guess what? The previous piece was already closed. So students, this is technically still closed, okay? All right, and then at 5, 5, 6, 5, doesn't matter what we plug in. Y for this third piece is always going to be 5. Even though two pieces are continuous, but the entire function, that means all three pieces, is not. So the whole function is not continuous. And that's it, students.